Hidden deep beneath these ancient mountains lies one of Earth's most valuable natural resources, gold. This massive open-pit mine operates day and night, moving thousands of tons of rock every single hour. Before mining begins, geologists carefully study the rocks to locate the richest gold-bearing deposits.
Deep core samples reveal how much gold is hidden beneath the surface and help engineers plan the mine.
Every sample is carefully analyzed to determine the exact gold content before excavation begins.
Mining engineers design every excavation step to maximize safety, efficiency, and gold recovery.
Powerful bulldozers prepare strong haul roads for the enormous mining trucks.
Smooth haul roads reduce fuel consumption and improve the safety of heavy mining vehicles.
Massive rotary drills create deep blast holes with remarkable precision.
Every hole is positioned according to a carefully engineered blasting pattern. Specialized blasting crews prepare the site under strict safety procedures.
A carefully controlled blast breaks apart solid rock while protecting nearby equipment and workers.
The freshly blasted ore is now ready to be collected and transported for processing.
Giant hydraulic excavators load hundreds of tons of gold-bearing ore into ultra-class mining trucks.
With every journey to the processing plant, the transformation from ordinary rock to pure gold moves one step closer.
After leaving the mine, every load of gold ore begins its journey through the processing plant. Each truck is weighed to accurately record the amount of ore delivered to the plant. Hundreds of tons of ore are unloaded into massive hoppers that feed the crushing system. Heavy-duty feeders control the steady flow of ore into the primary crusher. The primary jaw crusher breaks massive rocks into smaller, manageable pieces. Conveyor systems transport the crushed ore continuously through every stage of the plant.
Screens separate the material by size, ensuring only properly crushed ore moves forward.
Oversized rocks return for secondary crushing until the required size is achieved. Secondary crushing prepares the ore for fine grinding.
The crushed ore now enters one of the largest machines in the processing plant, the SAG mill. Inside the rotating mill, heavy steel balls and ore grind the rock into much finer particles.
Water is added to create a mineral slurry for the next stage of processing.
The ball mill further reduces the particles, helping release tiny gold grains trapped inside the ore. Hydrocyclones separate fine particles from coarse material for efficient processing. The finely ground slurry is now ready for gold recovery, where valuable gold will be separated from the surrounding minerals. The finely ground slurry now enters the gold recovery circuit, where engineers begin separating valuable gold from the surrounding minerals. Centrifugal concentrators use powerful rotational force to capture coarse gold particles before chemical processing begins. The recovered concentrate contains valuable heavy minerals, including visible gold particles. The remaining slurry continues to large leaching tanks, where dissolved gold will be recovered. The remaining slurry continues to large leaching tanks, where dissolved gold will be recovered.
Operators monitor every stage using automated control systems to maintain stable operating conditions.
Activated carbon captures dissolved gold from the slurry inside the carbon-in-leach circuit. The gold-loaded carbon moves through the recovery circuit while the remaining slurry continues onward. The loaded carbon is carefully washed before the gold is removed in the next stage. Inside the elution system, the gold is stripped from the activated carbon using a controlled industrial process. Heated process solutions help transfer the dissolved gold into a concentrated liquid. The concentrated solution enters electrowinning cells, where electricity recovers gold onto metal electrodes. A thin layer of recovered gold is collected from the electrodes for final refining. The recovered material is filtered to remove excess moisture before drying and smelting. The concentrate is carefully loaded into a high-temperature graphite crucible for smelting. Flux is added to help separate remaining impurities from the molten metal during smelting. Inside the furnace, intense heat melts the gold into a glowing liquid. Engineers continuously monitor the furnace to maintain stable melting conditions. Remaining impurities are removed from the surface before the molten gold is poured. The molten gold is carefully poured into preheated molds to form solid gold bars. As the metal cools, it gradually solidifies into a heavy gold bar. The newly formed gold bar is removed from the mold for final finishing. The surface is cleaned to remove any remaining residue from the casting process. Each bar is accurately weighed to verify its final production specifications. Advanced testing equipment confirms the purity of every gold bar before approval. Once approved, each bar receives a permanent identification mark. Every marking provides traceability, authenticity, and verified purity. From ordinary rock deep beneath the earth to refined gold bars, the transformation is now complete, ready for final packaging and secure transport. Every approved gold bar now moves to the final handling area for documentation and secure packaging. Each gold bar is electronically recorded to maintain complete production traceability. Production records are updated to verify every bar before it leaves the refinery. Protective packaging helps prevent scratches and surface damage during transport. Finished bars are organized into secure storage trays before final shipment. A final visual inspection confirms that every bar meets strict quality standards. The gold bars are placed into heavy-duty transport cases for secure handling.
Forklifts carefully move the sealed cases to the shipping area.
Shipping documents are verified before the refinery releases the finished gold bars. The sealed cargo is loaded for secure transportation to an approved storage facility. The finished gold begins its journey under carefully managed transport procedures. The destination is a highly secure bullion storage facility designed for precious metals. Inside the vault, every gold bar is stored in an organized and carefully managed environment. Each bar represents months of exploration, mining, engineering, and precision refining. From deep beneath the Earth's surface to a finished gold bar, this remarkable journey showcases the skill, technology, and after arrival, every shipment is carefully transferred to its designated storage location. Digital inventory systems accurately record the location of every gold bar. Inside the vault, thousands of refined gold bars are stored under carefully controlled conditions. Gold refining is a continuous industrial process that supports industries around the world.
A portion of refined gold is used in electronic components because of its excellent electrical conductivity and resistance to corrosion.
Gold is also transformed into jewelry, combining skilled craftsmanship with one of nature's most valuable metals. Gold bars are produced in different sizes to meet industrial and investment requirements.
Investment-grade gold bars are carefully inspected before being traded or stored.
Refined gold moves through regulated global supply chains to serve industries, financial institutions, and manufacturers. Every finished gold bar begins its journey with the extraction of ore from deep beneath the Earth's surface. Mining, processing, refining, and casting work together as one continuous industrial operation. Every stage demands precision, engineering expertise, and strict quality control. The result is a refined product recognized around the world for its purity, quality, and lasting value.
From exploration to the final gold bar, every step depends on planning, technology, and skilled professionals.
This is the remarkable journey of gold. From ancient rock hidden beneath the earth to a refined gold bar